Hello, it's Saturday, July 21st, 2012 at approximately 9 p.m. Central Time. I want to talk to you about something that I've observed happening around my home. I'll let these play while I'm talking here. This is College of DuPage radar, and I live right up in here. Now let me see. You're right in here. Several months ago, or a couple months ago, I arrived home one night about sunset, and it looked like it was raining out, but it was not raining out. I mean, nothing was wet, but it looked like a gentle rain was falling, and it was clearly evident where I looked like into dark areas or green areas of trees. And if you looked towards the sky, you didn't see it, and there was nothing wet on the pavement. And this happened night after night, and I tried to film it, but I don't think it showed up, just like a gentle rain. You know, it's a gentle rain, not a pouring rain, but a gentle rain. At first I wouldn't even go out in it, but I kind of got used to it. And this happened night after night, and then I kind of quit looking for it. But then today I noticed that it's happening again. And what happened months ago was mostly at twilight. And I did go to a different city once and noticed it happening in the afternoon, about 80 miles away. And it wasn't twilight, so I don't know, the time of the Terminator line coming through. So I don't know, whether it was happening at my house or not at the same time. But now it's happening again tonight. And I know that last night the air was highly excited. I did a video on it. And even tonight it still is, as you can see. Right here we're getting the Terminator beams coming through. And those are the beams that show up as the Terminator line passes over the United States. And also what's interesting is these striations. Notice that before they come, see the striations here? And then actually a beam comes out of here. Actually, it looks like a beam coming out of here and a beam here. Now I'm getting off track. And then this switches mode as the Terminator beam comes through. And then all kinds of dynamics going on. But anyway, this cloud passing over has been passing over for some time now today. And I'll go and this is the visible satellite. Let's slow it down just a touch. And there is kind of like an odd cloud here. See how it hangs horizontally across? As this is rotating, this is just kind of hanging there. It almost looks like it shoots in. See right there? Let's go a little slower even. And I don't know if that I didn't even have any idea what the rain was, but now I've got an idea because of this article that I read. Let me read the paragraph, I'll show you the cover page, but it says, let's see, right here. Another disruptive effect may play a role. Through the irregular heating of the ionosphere, the air at great heights begins to glow with visible frequencies in the near-infrared region, 630 nanometers, and the associated magnetic field can be detected at the Earth's surface. Now, I also read this in conjunction to our disappearing bees, but it's a report, and that specifically was talking about HAARP. But it's a really good report, and I'll put a link to it. Bees, Birds, and Mankind Destroy Nature by Electrosmog by Ulrich Warnke. So anyway, I went back to search for that today and ended up with in one of the footnotes. I don't have to show you that. And that led me here to this paper called Magnetic Zenith Enhancement of High Frequency Radio-Induced Airglow Production at HAARP. Now, this is somewhat technical for me. And so, let's see, there's a couple paragraphs I'll read you here. Observations. The HAARP optical campaign was carried out from February 1 through 21, 2002 at the HAARP facility near Gakona, Alaska. Several optical instruments were employed, including the HAARP Imager, which took all sky images at 630. Anyway, the launch angle experiments were first run on February 3rd, and experiments on subsequent days were revised to take advantage of the high levels of airglow seen when transmitting up the magnetic field, allowing strong airglow to be observed on all campaign nights with sufficient clear skies. And then it goes on to tell you how they did the experiment, and here it's showing you how it shows up. But what really caught my attention And it's when it's at vertical, let's see, the true zenith. Now the true zenith is marked with an X. See, you're going to have to read this yourself, and hopefully someone can help put this all together, because all I have is pieces at this point in time. But it talks about, let's see where it is. They actually talk about twilight in here. Let's see. I'm not seeing exactly where it is. Yeah, it's right in here. But that's what helped make a connection for me. Although I had kind of already thought it was airglow, but I don't understand why it looks like rain when they're talking about it going up the magnetic field line. So going on, this is an XSAT image. I'm not sure how this comes into it, but I find that these clouds are very interesting. This is the contrail setting for NextSat. And I'm right here actually where this green line is. And let me zoom in. So right in here. And pink equals ice clouds. And I'm not sure what the darker, I mean, maybe these are just regular clouds. And again, I'm just kind of rambling around here trying to find a connection, but also going to the troposphere report. What's happening right by my area is also interesting in that we've got a high and a low area. See the high and the low, the orange and the blue. But also we have a spot right here, red, with yellow on either side. And that's significant because there's fields that are made. You know, when you've got, like, here's a dark, in Utah, you've got this dark blue, and then you've got these orange things on either side. And it's something to do with an electric field or a magnetic field. I'm not sure which, but maybe that has something to do with it too. I've just now started trying to look at loops in conjunction with seeing this. So when I have time, I'll come and see if I can find some kind of constant thing that shows up. So, oh, there's one more thing. Let's see if we can find it quickly, because it's the Wikipedia for airglow. There's a pretty nice picture of it right here. It talks about HAARP. Let's see if I can zoom in. Yeah, good. Right here. 2 images of the sky over the HAARP Gakona facility using the NRL-coded CCD imager at 557.7 nanometers. The field of view is approximately 38 degrees. The left-hand image shows the background star field with the high-frequency transmitter off. Right-hand image was taken 63 seconds later with the high-frequency transmitter on. Structure is evident in the emission region. And I've seen pictures, someone had a video, and it was about a ghost, and you know, that ghost looked almost exactly like this. So I think some of the ghosts that we are seeing is due to airglow. And actually, I don't believe in ghosts, but I do believe in demons. And so I know that they can manifest themselves. And that's more likely what it is. And I don't really want to get into that because that's a whole nother area. But going back to this report, which I don't know if I read the title. Yeah, I did. But it's by T.R. Peterson, Emma Carrick, E. Gherkin, C. Selcher, D. Sentman, H.C. Carlson, and A. Gurevich. And on the last page, again, I only understand part of this. The February 2002 HAARP observations have several implications for the theory of high-frequency radar-induced airglow generation. The self-focusing characteristics and extreme sensitivity of the magnetic zenith spot provide general support for the Gurevich et al. Striation theory, which has been explained upon in consideration of these new results. Observation of intense green line emissions, which I don't know what that is, I probably need to check that out, and low red-green ratios is a strong, if not definitive, indication of a sizable suprathermal contribution to the airglow excitation, contrasting with the thermal interpretation of earlier airglow observations at HAARP. Airglow observations over a wide range of transmitter and ionospheric frequencies provide many test cases on both sides of the 5 to 6 megahertz threshold discussed by these authors as the divide between thermal and superthermal excitation regimes. The large apparent delay in green line excitation, while reminiscent of the lag expected from thermal time constants and inconsistent with direct wave excitation of the short-lived O state, is perhaps more likely to be an indication of larger scale transport and rearrangement of the plasma required under a self-focusing process such as that of Gervich et al. To produce the high power densities favoring superthermal excitation. And then there's an acknowledgement here. The HARP program is a Department of Defense project managed jointly by the U.S. Air Force and the U.S. Navy. We thank P. Ning and C. Moore for assistance maintaining our equipment and archiving the data. Work at AFRL was carried out under task 2311AS. And I skipped a couple things that I did not know how to talk about. F delta, F2, I'm not sure. So anyway, that's what I found, and hopefully this can help somebody else put some of the pieces together. God bless you all, and I praise the Lord for leading me along. He does lead his dear children along. God bless you. Have a good night.